This is my first session of Chapter 4, Theoretical Concepts of Operating System. A computer has two major components, hardware and software. Hardware is the physical components associated with the computer. Software is a set of instructions that make the hardware to work. Here are some of the hardware of a computer. Software is classified into system software and application software. System software is designed to run the computer's hardware and application programs. The most important system softwares are operating systems, utility programs, and compilers. Application software are programs designed to perform a specific task. Here you can see some of the application softwares. A computer is a mixture of different types of hardware and software, but there is one program that brings them all together, and that is nothing but the operating system. Here are some of the popular operating systems: Windows, Apple, Android, Linux, Unix. Operating system acts as an interface between the user and hardware. Uses of operating systems: to make the computer to do what the user wants, to ensure easy interaction between the user and computer, to start computer operation automatically when power is turned on, to control input and output devices, to manage utilization of main memory, to provide security to user programs. There are two types of operating systems: single-user operating system and multi-user operating system. Single-user operating system allows only one user to access the computer system at a time. Example, MS-DOS. Multi-user operating system allows more than one user to access the computer system at a time. Examples, Windows, Unix, and Linux. Now let us see the key features of operating system: user interface, memory management, process management, security management, fault tolerance, and file management. The first feature is user interface. The operating system should be a user-friendly graphical user interface. GUI is a window-based operating system which uses a pointing device such as a mouse to click on icons and select from menus and a keyboard to enter text. The user interface should be designed with the following considerations. The user interface should be pleasing to the senses, reduce the errors committed by the user, reduce typing by incorporating menus, windows, tabs, and icons, enable the user to retain this expertise for a long time, and satisfy the customer. The second feature of operating system is memory management. Memory management is the process of allocating memory blocks to user programs, improving both the utilization of the CPU and speed of the memory. In connection with memory management, the operating system should keep track of which portion of memory are currently being used and who is using them, determine which processes and data to move in and out of memory, allocate and deallocate memory blocks as needed by the program in main memory. The third feature of operating system is process management. First, we will see what is a process. A process is a unit of work or job done by the CPU. There are two types of processes: operating system process and user process. Operating system processes are executed by system code. User processes are executed by user code. In connection with process management, the operating system should schedule processes on the CPU, create and delete both system and user processes, provide mechanism for process synchronization, suspend and resume processes, provide mechanism for process communication. Operating system uses the following process management algorithms to allocate jobs to the CPU. There are 4 process management algorithms: FIFO, SJF, round robin, based on priority. FIFO stands for first in, first out. This algorithm is based on queuing. The process that enters the queue first is executed first by the CPU, and then the next, and then the next, and so on. Process 1 enters the queue first and is executed first by the CPU. Then process 2 will be executed, and so on. The processes are executed in the order in which they enter the queue. SJF, shortest job first. This algorithm is based on size of the job. The shortest job is executed first by the CPU. Take 3 jobs A, B, C. Let size of job A be 8 kilobytes, size of job B be 3 kilobytes, and size of job C be 6 kilobytes. The shortest job B is first assigned to the CPU. Next, job C is assigned to the CPU, and then job A is assigned to the CPU. Round robin. This algorithm is based on assigning processor time in a circular method. Round robin algorithm is designed especially for time sharing systems. Take 3 jobs A, B, C. First, job A is assigned to the CPU, then job B, and then job C, and then again job A, job B, job C, and so on. Based on priority. This algorithm is based on priority of the job. The job with higher priority is executed first by the CPU. Take 3 jobs A, B, C. Let priority of job A be 5, priority of job B be 7, priority of job C be 6. Job B, which has the highest priority, is first assigned to the CPU. Next, job C is assigned to the CPU, and then job A is assigned to the CPU. The fourth feature of operating system is security management. Operating system provides 3 levels of security: file access level, system level, and network level. File access level. Operating system provides to set file access permission by the creator of the file or by the system administrator. System level. Operating system offers system security by allowing the user to set up username and password. Network level. Operating system provides network level security by using firewalls. Fault tolerance. The operating system should have fault tolerance capabilities to overcome the mistakes or errors done by the user. File management. File management is an important function of the operating system which handles the data storage techniques. The operating system manages the files, folders, and directory systems on a computer. What are files? All data or information in the computer are stored as files. Therefore, a file is a collection of data or information. What are folders? A folder is a collection of related files or subfolders. A table called File Allocation Table is maintained by the operating system, which shows where directories and files are stored on the disk. File Manager of the operating system helps to create, edit, copy, allocate memory to the files, and update the file allocation table. The operating system also takes care of the files that are opened with proper access rights to read or edit them. The other file management techniques are Next Generation File System (NTFS) and ext2 of Linux. That's all in this session. Thank you.